Guys, let's talk about the question 7 in the homework 3. Okay, we have the table and main memory access will take 70 nanoseconds and 36% of the instruction will want to get data. And we have the table for the processor 1 and 2. Alright. Okay, so let's go with part A. Part A will say the heat time determine the clock cycles. So for processor 1 and processor 2, the heat time is 0.66 nanosecond and 0.9 nanosecond. And when you get it reverse, it will give you this kind of GHz, right? And what is this? Okay, it's 1.11 GHz. So this is the clock rate. Okay, so part A is quite easy. Let's go to part B. Part B is one us to get AMAT for each processors. Okay. So what is the miss rate for each processors? Yeah, we still need a table. Miss hit. Miss rate is the 8% and for processor 2 is the 6%. Okay, that's good. And go to the main memory, it will take us 70 nanoseconds. So how many cycles is it? Yeah, we need to divide it by 0.66, and this will give us 100. You will get something cycles like this, right? But actually, cycles cannot be a decimal. It should be a integer. So we should round it up to 107, right? And here we'll do the same thing for processor 2. It will give you 78. Just round it up, go to the 78. So we will use 107, 107 and 78 to be our miss penalty for the L1. Okay. Yeah. And then I think we can do the AMAT now. AMAT 1 for the processor 1 will be, yeah, surely we will have a hit if we have a hit, and the percentage of the miss rate, and with our penalty 107, here we will give us okay, 9.56 cycles. And AMAT2 will still do nearly the same thing, 6%, right? And with the miss penalty is 78. Here will give us 5.68 cycles. Okay, so yeah, if you want to say it in a nanosecond, we can change it, right? With it multiplied by our clock rate 0.9. Here we'll multiply by our clock rate 0.66, and okay, so here will give us like 5.11 nanoseconds, and here will give us like 6.31 nanoseconds, right? So you can say it. This kind of answer are all correct, right? Okay. So in part C, what we want in part C, we want to actually compare which one is faster. We need to calculate the CPU time. So both of them, okay, I would say CPU1 and CPU2 to represent the two processor, okay? CPU1 and CPU2, initially we will have like one CPI, basic CPI1, right? Without any stores. And then we will nearly do the same thing. We have 8% or 6% of the miss, right? And what's new is that when you think of the CPU, we will think of the instruction fetch and data fetch, right? And 36% of the instruction we will need to fetch data. We will want to get data from the main memory, access data memory. So that's then another thing we need to consider, right? The 36% of the instructions will need to fetch the data. So we will also have 8% of the miss and with the penalty, and with 6% for the processor 2. So that here is actually what's the difference from the question B or part B. Part B just need to the average main memory access time. And for part C, we need to calculate the CPU. We need to think more than the part B. So yeah, actually just the right 1 plus 1.36 multiplied by 8% and 107 1.36. Here they are the same, right? And by 6% by 78. Okay, so what will we get here is 12.64 cycles, and here will be the 7.36 cycles, right? And you can say it's when you multiply by 0.9 nanoseconds, it will be 6.63 nanoseconds. And when it like multiply by 0.66, it will give you 8.34 nanoseconds. Yeah. So this is the kind of the solution or analysis for part A, B, and C. And then we'll go to the part D. That's another big part. Oh, I forgot that we need to compare which one is faster in the part C, right? So that's quite obvious, right? The 6.63 is smaller than 8.34, so P2 is better or faster, okay?